This video is about gravitational field strength. Gravitational field strength at a point is defined as the force per unit mass experienced by a small point or test mass that is placed at that point. We'll explore the meaning of this definition in a bit more detail. Let's take a spherical object, for example a planet, with mass uppercase M. Of course, as the object has mass, a gravitational field arises. Logically, the strength of the gravitational field will be different at different distances from the object. Let's assume that we want to figure out the gravitational field strength at point P, which is at a distance r from the center of the object. So this is how we can sketch the object and point P. Let's see how we can use the definition above to find the gravitational field strength at P. As per the definition, we'll place a point mass, also sometimes called a test mass, at P. Let's denote this point mass using lowercase m. Based on Newton's law of gravitation, the spherical object and the point mass exert a gravitational force on each other. The gravitational force experienced by the point mass is towards the spherical object, and we'll label this force using uppercase F. Now, using the formula for Newton's law of gravitation that we learned earlier, we can write an expression for F. Doing so, we get the gravitational constant multiplied by uppercase m times lowercase m divided by r squared. Returning to our definition on the left, we can see that gravitational field strength is the force per unit mass experienced by our point mass. The letter symbol for gravitational field strength is lowercase g, and based on the definition we can write that lowercase g is equal to the force per unit mass experienced by the point mass, so F over lowercase m. Substituting this expression for F into our second equation gives us lowercase g equals to uppercase G times uppercase m times lowercase m divided by r squared divided by lowercase m. To complete our working, we'll simplify by lowercase m. Hence we've ended up with the two gravitational field strength formulae that are provided in the data booklet. We'll summarize these formulae and the variables in two tables. From the first formula, we can easily deduce the unit of gravitational field strength, which is newtons per kilogram. You might have noticed that the letter symbol for gravitational field strength is the same as for the acceleration of free fall or gravitational acceleration, which, near the surface of Earth, is about 9.8 meters per second squared. This is not simply a coincidence, because there is a close connection between gravitational field strength and gravitational acceleration. According to Newton's second law, force is equal to mass times acceleration, so acceleration is equal to force divided by mass. Based on this, we can write that gravitational acceleration is equal to gravitational force divided by mass. As you can see, this equation is equivalent to one of the gravitational field strength formulae that we found earlier. Therefore, we can conclude that at a given point, the magnitude of the gravitational field strength is equal to the magnitude of the gravitational acceleration. This magnitude near the surface of Earth is about 9.8. When expressing the gravitational acceleration, or in other words the acceleration of free fall, we use the unit meters per second squared, while for gravitational field strength, we use newtons per kilogram. Of course, these two units are equivalent. With this, we have completed our video about gravitational field strength.